what we're going to do now is we're going to talk about the different Java programming paradigms that we've covered throughout this semester, some of which you knew from before coming into the course because you've probably been programming with them for years, and others of which we've discussed throughout the last 13, 14 weeks or so. And then we'll also talk about the pros and cons of using reactive streams versus alternatives, which largely end up being various points in this chart with the 4 different quadrants. So let's start off by talking about how to compare and contrast different paradigms for programming in Java. So reactive programming is just one of many Java programming paradigms, and I've organized them into this 4-fold chart where we have the dimension of synchronous versus asynchronous processing and programming in the bottom on the x-axis, and then we have single value versus multiple value results on the y-axis. So let's start by taking a look at the lower left-hand quadrant, where we have a single value which has synchronous semantics. In other words, calls that are made on methods will block. And this is the classic way of doing things in Java. You undoubtedly, hopefully, I'm sure you did, came into this course having a good intuitive feel for how to program to synchronous calls that return a single value. That's just the way Java works out of the box since day one. And what's interesting about this is this was kind of uncool for a long time because it would cause your program to be very unresponsive and you had to allocate large numbers of threads and so on and so forth. But nowadays, with Java virtual threads and Java structured concurrency, all of a sudden, synchronous programming is cool again. So we haven't talked a whole lot about that in this course, but in my course in the spring, we'll talk a lot about virtual threads and structured concurrency because it's very new. And it's also widely used for doing microservice style communication in client-server environments. Up here in the upper left-hand quadrant is synchronous programming that uses multiple values. And of course, the canonical way of doing this in modern Java is by using Java parallel streams, where by default, the operations you invoke are synchronous. You can make them run in parallel by using a parallel stream. And since it's a stream, you end up with a stream of values. You have multiple values being applied and leveraged in the context of parallel streams. So that's this part of the quadrant. And as we've talked about before, as you've got a chance to play around with in class, pretty cool paradigm, scales up nicely, fairly easy to program once you understand how to do Java sequential streams. In the bottom right-hand quadrant, we've got single value asynchronous processing. And of course, that's where Java Completable Futures come in. You've had a chance to play around with Java Completable Futures. They allow asynchronous computations that return a single value. So you can see here where we can start up something, have it run asynchronously in the background, and then chain a bunch of completion stage methods that will process the results when earlier stage completion methods or earlier stage factor methods complete and trigger the completable future at its finalization. And then finally, we have the upper right-hand quadrant. And this is the quadrant where we've been focusing the last few weeks and where we'll be focused the last few weeks of this course, which is asynchronous processing with multiple values. So up to this point, we've talked primarily about how to achieve this, where we have Java sequential streams and completable futures. So that gives you this asynchronous multiple value approach, and that works pretty well. But what we're really going to focus on the rest of the semester is the upper right-hand corner, which is the reactive streams part of this quadrant, where we have asynchronous processing that can handle multiple values. And as you'll see, this comes baked in to reactive streams, whereas with streams plus completable futures, you had to kind of combine 2 paradigms, which worked okay, but it isn't quite as seamless as the reactive streams model. So I know we haven't talked a lot about reactive streams, but let me give you a preview of the pros and cons just so you'll be able to set your expectations accordingly. So reactive streams implementations apply reactive programming principles to achieve several benefits. One is to support concurrency with a minimum number of Java platform threads or traditional threads via a whole range of different thread pools, like we've talked about with computation thread pool for CPU-bound tasks, or the I/O thread pool for I/O-bound tasks, and so on and so forth. And what's nice about this is it allows you to be able to scale up performance of your applications without using a lot of underlying threading resources and memory to support those threads. So if you take a look at the link at the bottom, it compares the performance of a WebFlux program, which is, again, this cool client-server web-based framework that uses Project Reactor. And it compares that with a more traditional web MVC style architecture, which has a bigger pool of threads, of traditional platform threads. And you can see that you can get better performance with a smaller number of underlying threads, underlying platform threads. Something else that's nice here, which is really falls right in line with what we've seen before with parallel streams and completable futures, is that explicit synchronization threading is rarely needed when you use these frameworks, which helps to alleviate lots of complexities, especially accidental complexities of concurrent and parallel programming. These benefits, however, are not unique to reactive streams. So you can get pretty much the same benefits by using parallel streams or completable futures or structured concurrency for that matter, just different ways of achieving the same kind of benefits. Keep in mind, however, that reactive programming is not appropriate for everything. In particular, it turns out that there's a learning curve that you have to climb and master successfully in order to be able to use reactive streams and reactive programming effectively. Most of us, myself included, started out with an object-oriented view. And so learning functional programming was a bit of a learning curve. Then learning reactive programming is more of a learning curve. And if you want to learn a bit more about some of the challenges of trying to apply reactive streams, take a look at this video down below, which kind of walks through the pros and cons of this paradigm. And the point that the speaker, whose name is Thomas Nukowitz, makes is that reactive programming really starts to shine when you get larger scale systems where they're more and more complicated, because then it's worth the effort to master the learning curve. Now, of course, all this stuff needs to be reevaluated once we understand how Java virtual threads and structured concurrency work, but I'll leave that as a discussion for another class. Another challenge here, of course, is that debugging reactive programs and programs with asynchronous operations can be difficult due to the lack of meaningful stack traces and the fact that it's just hard when you start having things running asynchronously to know when they run and how to set the breakpoints and what to do if something goes wrong. And of course, if you don't write bugs in the first place, you don't need to debug your code, but that's always easier said than done. So key thing to remember, which of course is motivating what we're doing in this class, it's essential to master the learning curve of reactive programming in order to use it effectively. When you master the learning curve, you can be both productive and achieve high performance of the computing infrastructure. But there's some effort that's required to do that effectively. There's also some interesting perspectives, of course, somewhat biased, by people who are proponents or promoters of other concurrency models. For example, Brian Getz and other folks like there's other people who are supporters of structured concurrency have gone on record as saying they think that the virtual threads features that are available now in very modern Java are going to kill reactive programming. I'm not sure I necessarily subscribe to that. There's some benefits I still enjoy. I actually honestly enjoy doing reactive programming better than structured concurrency, but I think it's worth being aware that other people like Brian Getz and Ron Pressler and so on have different perspectives on this, and they're well-respected folks in the Java community. So that's the end of the discussion of Java programming paradigms and comparing and contrasting the different approaches.